Alright, good night everyone. So I'm going to be doing chemistry paper 2, May-June 2022. Okay, so we have the first question. As usual, it's a long question, and we have to read the materials. It says, an experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid, and the procedure is given below. So it says 100 ml of 0.5 moles per dm cube hydrochloric acid was measured and placed in a calorimeter. Sandpaper was used to clean a strip of magnesium ribbon until shiny, and 0.48 grams was weighed using a balance. The temperature of the hydrochloric acid in the calorimeter was measured every minute for 5 minutes until a constant temperature was obtained. The magnesium strip was then added to the calorimeter with hydrochloric acid. While stirring gently with the thermometer, the temperature was recorded every 15 seconds for 2 minutes. Figure 1 shows the first 5 thermometer readings taken during the experiment. Alright, so we have to read the thermometers. The picture format of the thermometers. So remember, when you're reading a thermometer, the reading increases going up. Okay, so the first reading is 33 for 15 seconds. At 30, it's 39.5. Then we have 43, 44.5, and then 46. Then it says here, using the grid provided on page 7, plot a graph of temperature against time using the data in table 1. Draw the best curve through the points. Now, using your graph, determine the temperature change. So what I did the graph, I drew it, and please note that every 2 spaces was 1 point, right? So that's every 2 is 1 point. So I have it here, as you can see. So you have 35 every 2 spaces, you add 1. 36, 37, 38. Now I put my points, and I put a circle around my point because you want the marker to be able to see your points, right? You just be a little courteous here. So once these points are circled, I drew my curve, and then I did my temperature change, and I saw that the lowest temperature was 25, the highest was 46. So the temperature change would be the difference of the 2 numbers. You get 21 degrees Celsius. And you state one difference between endothermic and exothermic reactions. Well, heat is taken in during endothermic reactions, while heat is given out during exothermic reactions. Now, this was an exothermic reaction because heat was given out. Now, it's a state whether the reaction, right, so heat was given out, right? Because there's an increase in temperature. Alright, so write a balanced chemical equation including state symbols for the reaction between magnesium metal and hydrochloric acid. And you see here that the magnesium metal, when it reacts with hydrochloric acid, you get MgCl2 plus H2, which is a gas. Whenever a metal reacts with acid, you always get a salt and hydrogen gas being given off. And then all it had to do was balance, and here's the balanced equation. And also make sure you put your states in, which is the solid for the metal, the aqueous for the acid, aqueous for the salt, because this is a soluble salt, and then the H2 was gas. Now it says calculate the number of moles of magnesium used in the reaction. Well, they told us that 0.48 grams of magnesium were used. So from our knowledge, we know that 1 mole of magnesium will have a mass of 24 grams. Now all you need to do is figure out how many moles has a mass of 0.4 grams. So you relate the two, and then you just cross multiply. So you would have 1 mole times 0.48 grams divided by 24. Like so, we'll carry this up. This is actually a fraction of 1 over x equal to 24 over 0.48. So now to solve for x, I would just put x across here, move 0.48 by 1 and divide everything by 24, as you can see here, and we get x is equal to 0.02 moles of magnesium. Now it says determine the volume of gas that will be collected if the reaction took place at STP. So seeing as how we have 1 mole of magnesium producing 1 mole of hydrogen gas, we just relate it, so 1 to 1, so you can definitely get 0.02 moles of hydrogen gas. So if 1 mole of any gas occupies a space of 22,400 cubic centimeters, right, at standard temperature and pressure, then how much space would 0.02 moles of hydrogen take up? And again, this is a fraction that you would just transpose. You would make x the subject of the formula. So you end up with 1 over 0.02 equal to 22,400 cubic centimeters over x. You solve for x by transposing x on one side, and you will end up with an equation like this. And you end up with 448 cubic centimeters of hydrogen will be collected. Okay? Alright, so then it says here, calculate the energy change for the reaction between magnesium and hydrochloric acid. And we had to do some assumptions. We had to assume the specific heat capacity of the solution was 4.2 joules per gram degree Celsius, and the density of the solution was 1 gram per cubic centimeter. And we're going to do the enthalpy of reaction, which would be mass times specific heat capacity times the temperature change. So we are given the specific heat capacity, we're given temperature change. We just need to use the mass and the mass of the acid, which would have been the volume of the acid. But since we're going to take the density to be equal to 1 gram, right, we just say 100 plus the mass of the solid, which was the magnesium. Okay, so you would have gotten 8,862.336 joules. Okay, and then we had to now determine how much heat would have been given off if 1 mole of magnesium were used. Right, so seeing as how we use 0.02 moles of magnesium, we see that this amount of magnesium produced this amount of heat, right? Now we need to figure out how much 1 mole of magnesium would have given off if we were using 1 mole. And again, this is a setup where we have a fraction of 0.02 over 1 equal to 8862.336 over x. We solve for x by transposing. X will go up, the 1 will go up, and 0.02 will come down, and we end up with 443,116.8 joules. Shortened form to kilojoules, we get 443.1. And since heat was lost, we just put a negative sign in front to indicate that. You don't have to do it, right? But yeah. All right, so for question 2 now, it says, steels alloys widely used in industry in place of iron metal. Define the term alloy. So an alloy is a mixture or solution of 2 or more metals, and some alloys contain non-metals. In this case, steel is one of those alloys, right? So the 2 types of steel, we have high carbon steel, which is an iron alloyed with 0.25% to 1.5% of carbon, and carbon here is a non-metal. And then we have stainless steel, which is about 70% iron alloyed with 20% chromium and 10% nickel. Then it says state 2 enhanced properties of steel. Well, it has increased strength, it is resistant to corrosion, its hardness has been increased, and decorative purposes, right? Now, so I put more than 2. So in case it had these, you're correct. So it says many metal nitrates undergo thermal decomposition. The relative ease of decomposition and products formed can help determine their place in the reactivity series. Table 2 below shows the products formed from the heating of the nitrates of 5 different metals, V, W, X, Y, and Z respectively. So here we have the table. We have VXY producing metal oxide, nitrogen dioxide, and oxygen, and W and Z producing a metal nitrite and oxygen. So using the information from table 2, you have to state which metals would be the more reactive metals and which metals would be the least reactive. Well, the more reactive metals would form a metal nitrate and oxygen. So W and Z would be the more reactive metals. And then, by process of elimination, what's left? VX and W. So the least reactive, or the lesser reactive metals, will produce a metal oxide of itself, nitrogen dioxide, and oxygen. Alright, so if one of the more reactive metals was identified as sodium, so write a balanced chemical equation for the decomposition of sodium nitrate. So they already told us that if you're a reactive metal, over here they gave the answers. So if you're a reactive metal, the product would be a metal nitrate and oxygen. So once you know how to write the nitrate part of it, you're good to go, which is NO2. So you say NaNO3 will give you NaNO2, which is the sodium nitrite, plus oxygen, right? Don't forget to put in your states, right? So we have a solid, and a gas. Now it says, further tests were carried out with metals VX and Y. Each metal was the oxides of the other metals in displacement reactions. Now V did not react with any of the metals, so that means metal oxides, so that means V is last. Once it doesn't react, it's least reactive. Then it says X reacted with the oxides of metals V and metal Y. So that sounds like the most reactive. And Y reacted with the oxide of metal B. So it didn't react with Y, because that means it would be lower down than, it didn't react with X, which means that it would be lower down than X. So the order would be that X is more reactive than Y, and Y is more reactive than V, V being the least reactive. Okay, so tests were carried out in solution A to determine the cations present, and the observations are presented in table 3. So it says, complete the table by inserting the inferences based on the observations. I did not like this table at all, because they used solution A and they added sodium hydroxide to both test tubes containing solution A, and this can confuse students, because if I add sodium hydroxide to the same solution A and I get a green precipitate in one observation, and in the second observation I get a colorless gas being evolved, and no mention of a green precipitate. What I was saying was that this can be quite confusing for students, simply because solution A is solution A, and if you're adding sodium hydroxide, you have one observation here telling you get a green precipitate, and the next observation telling you that you got a colorless gas, right? And that a colorless solution was formed. You just had a green precipitate up here. So I don't think that this question was very fair, but let's try to answer it. So basically, if you get a green precipitate on the addition of sodium hydroxide, this is a test. The hydroxide part of the sodium hydroxide solution is an ion that is used to test for like iron 2, iron 3, and copper, right? Ions. And seeing as how we got a green precipitate, we know that Fe2 plus ions are present. Then the next observation was that the green precipitate darkened when left to stand and turned orange at the top of the test tube. This is a definite indication that Fe2 plus ions are present, because what's happening here is that the Fe2 plus ions are oxidized into Fe3 plus ions. It's not that they were present in the solution, but that the Fe2 plus ions actually oxidized to form Fe3 plus ions. So basically I will put that Fe2 plus ions are definitely present, and iron hydroxide was formed. So I write my little half equation here, and if you want, you could actually add in that the Fe2 plus ions oxidized to Fe3 plus ions. So you could put that as an extra step in here if you wish. I would actually encourage it that you put that extra step here to indicate that the Fe2 plus ions oxidize to Fe3 plus ions. Okay, and so a few drops of dilute sodium hydroxide were added to a small portion of solution A in a test tube. The same solution here, and says the test tube was heated gently. Now, if iron hydroxide is in there, heat is not going to dissipate, it's going to stay there. So the only other thing with this observation saying colorless gas evolved with a pungent odor. The gas turned damp, red litmus paper blue. From our qualitative analysis chapter, you would see that would be ammonia gas possibly being given out. The colorless solution form proved that ammonium ions were present. What I needed to say was that, it found white dense fumes when HCl was placed above it. That would have been a better thing. But anyway, hey, I didn't write the test. So if you have this, you're quite fine. But don't forget to write Fe3 plus ions were, Fe2 plus ions oxidized, right? Fe2 plus ions oxidized. So there was a loss of electrons. So you would have Fe2 plus arrow, Fe3 plus an electron. Okay, that would be the setup. Maybe I should write it so you could see it. I'll write it right under here. So let's say here, just trying to get my, okay. Put it here. So I will put Fe2 plus, oxidation is loss of electrons, so we put the plus E here, and we have Fe3 plus, and we're going to put our states AQ. So you could put it like that, right? So that the Fe2 plus ions became oxidized to Fe3 plus, which was the reason why you had that yellowy rustic color at the top. Okay, so now we're moving on into organic chemistry. It says figure 3 shows compound A and compound B, which are from different homologous series. Now it says state the homologous series to which compound A belongs. So we have to look closely at the drawings, and we must take note of the functional group. So once you see this functional group here, C double bond OOH, it belongs to the carboxylic acid homologous series. Then it says state the functional group of compound A is the carboxyl group. Then we have here state the name of compound A, that's butanoic acid, because we have 1, 2, 3, 4 carbons. Now state whether compound A will undergo a condensation reaction or addition polymerization reaction with alcohols. It will go through condensation. Okay. Now state the homologous series to which compound B belongs. Compound B has a double bond between 2 carbon atoms. That's indicative of an alkene. Write the functional group of compound B, that's the double bond between 2 carbon atoms. Okay. Then to state the name of compound B, and that'll be butene because we have 4 carbon atoms in this chain. This is figure 4 shows compound C, which has structural isomers, and it says define the term structural isomers. Well, structural isomers have the same molecular formula, meaning have the same amount and type of atoms, but the atoms are arranged differently, or the isomer has a different structure geometrically. As you can see over here, I've drawn my isomers for this over here, which is pentane. 1, 2, 3, 4, 5 pentane. So pentane, the first isomer I drew was 2,2-dimethyl propane. So I have 2 methyl groups on the second carbon in this 3-chain molecule. And then the next isomer was 2-methyl butane. So I took one methyl group, put it on the second carbon here. Now note well, if I put a methyl group here and put a H here, this would be also 2. So always start closest to where the branch is. So this one is 2-methyl butane. Okay, now question 4. Question 4 is dealing with electrolysis. Electrolysis tends to be a problem. So it says figure 5 shows a line diagram representing the electrolytic cell used in the electrolysis of aqueous copper to sulfate solution using copper electrodes. Okay, so it's a state where the electrodes used are active or inert. Give a reason for your answer. Well, the electrodes are active because they're made up of the same type of metal present within the electrolyte. Okay, and it says describe what occurs at the cathode and anode in an electrolytic cell. Well, at the cathode, we know reduction occurs. So, you know how we remember that? We say red cat. Okay? Do you remember that? We say red cat. Red cat. For the cathode, reduction at cathode, and we say anox. And this is oxidation at anode. Okay, so that's what we remember. And remember, you have to remember things like Rig. Reduction is gain of electrons, and oil. Oxidation is loss of electrons. So we know that at the cathode, reduction occurs. This is where cations gain electrons, right? While at the anode, oxidation occurs. This is where anions lose electrons. Now, it says state which electrode in figure 5 on page 16 is the cathode and which electrode is the anode. Now, all you gotta do is to look at which part of the battery these electrodes are hooked up to. So A is hooked up to the positive end, and we have the positive thing here. So if A is hooked up to the positive end, and this is the positive electrode, and the positive electrode is the anode, and B would therefore be the cathode. Right? So the anode and the cathode. And it says identify the ions that will migrate to the cathode and anode. So remember, cations migrate to the cathode and anions migrate to the anode. And since they said it's an aqueous solution of copper sulfate, we already know we have copper in there and we have sulfate anions in there. If it's dilute, then we also have hydrogen ions in there and hydroxide anions in there. So we have two cations in there and 2 types of anions in there. So the cations will be attracted to the cathode, the anions attracted to the anode. Then the actual half equations at the cathode and the anode. So first of all, we have to note that we have to recognize that at the anode and the cathode, at these electrodes, preferential ions are often they often get attracted to the electrodes first, right? And these preferential ions are the ones that are lowest in the reactivity series. So you would use the reactivity series for this one is please send Charlie's monkeys and zebras in large high cages most securely guarded. Please send Charlie's monkeys and zebras in large high cages most securely guarded. And so this is potassium, this is sodium, this is calcium, this is magnesium, this is aluminum, this is zinc, this is iron, lead, hydrogen, copper. Now if you look at it, hydrogen is above copper, so this one will be sorry, hydrogen is higher than copper, so copper will come off at the cathode because it's lower down, right? So copper will come off first, as we can see here, but I'm gonna circle it just so you see it. And then for the next one, I made up this mnemonic. It says Fiona's sun never comes by in October. So these are for the anions, and we see here that the sulfate anion is rather high up and the hydroxide anion is lower down. So the hydroxide ion will be preferred, and it's a dilute solution. So we have here at the cathode this half equation where reduction is taking place. So we have the addition of the electrons on the left hand side of the equation to reduce copper ions to copper atoms, and then with the hydroxide anion it's an oxidation. So what's going to happen is that we're going to have the electrons on the right side of the equation, because if it's an oxidation we lose electrons, so it will look like this if you write it up first. What I would tell people is write it up first, subtract on the first, on the left hand side first, and write in your products, right? And then from there, once everything is balanced, right, this is a plus sign, then we would just add the negative electrons to both sides and we're good to go, right? So pretty much, yeah, and we have this equation here. Okay, so it says using your answer in part B2, explain where a redox reaction took place during the electrolysis of the copper to sulfate. Well, copper to ions were reduced to copper atoms because the copper went from a +2 state to a 0 state by gaining electrons at the cathode. Okay. Now, the cathode, so it says just one change that is likely to be observed at the cathode. The cathode will grow in size, it will get fatter as copper 2 ions are attracted to it to gain electrons to become reduced to copper atoms. Now explain how the electrolytic cell can be modified to plate copper onto a small piece of steel. Okay, so the copper cathode can be replaced with a piece of steel. The electrolyte and everything else can stay the same. Once the circuit is closed, the copper 2 ions will come out of solution to coat the cathode, which is a small piece of steel. Okay, so moving on to question 5, it says, state 4 general characteristics of a homologous series. Well, they have the same general formula, they have the same functional group, similar chemical properties, show a gradual change in physical properties as the number of carbon atoms in the compounds increases. Then it says to write the general formula of the alcohol homologous series and the molecular formula of the 5th member of the homologous series. Now, since it was a short one, I drew it out, but let's go with the general formula. It says CN H2N plus 1 OH, and it matches. So you would have 2 times 5 will give you 10, plus 1 will give you 11 OH. And if you add that, if you do the drawing, you will see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrogens, and we write the OH separately in the thing. So we have our carbons, the hydrogens here, and we write the OH separately from this so that we can see the functional group here. Okay, so this functional group would indicate to us that we're dealing with an alcohol. If we were to write it in a condensed format, we could actually, it wouldn't be an indication that it's an alcohol. If we wrote it like this, C5H12O, this could actually be another type of 1, 2, 3, 4, 5. This could be another type of molecule, because if I put in my H's, it would be the same amount of H's. You have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this could be a whole different type of molecule. It wouldn't be an alcohol for sure. This looks like, right, this is an ether. All right, this is an ether. This is a whole different homologous series. So that's why it's written like this. All right, so figure 6, I think figure 6 was cute, a nice cute question. So figure 6 shows the fully displayed structure of compound D. It says circle any two functional groups shown in the structure. So I circle all so that you could see. I circle the carboxylic group, well, the carboxyl group. I circle the single bond to indicate the alkene, the double bond to indicate an alkene being present, the ester linkage, circle that. So if you had any of these, you should get them correct. It says experiments were carried out on 2 hydrocarbon gas samples, E and F, to determine which gas is ethane and which gas is ethene. Table 4 presents the experiment and observations. So we have each hydrocarbon was bubbled through bromine water. Hydrocarbon E turned the bromine water colorless, so it went from orange to colorless. And hydrocarbon F, and no reaction. So state the difference between alkanes and alkenes. Well, alkanes are saturated. They contain single bonds between the carbon atoms, and while alkanes are unsaturated, they contain double bonds between carbon atoms. Hence, alkenes are more reactive than alkenes. Now, using the observation in table 4, you need to identify hydrocarbons E and F. The alkene would be hydrocarbon E because it reacted with the bromine, while hydrocarbon F did not, which would be the alkane. Now it says state the conditions under which an alkane would react with bromine. You would need to apply ultraviolet light. Now write a balanced chemical equation including state symbols for the burning of ethene gas in air. So what I did, I drew it out. I drew the structural formula out. And you see here, ethene. It says ethene. So that means we have a double bond. So it was C2H4 gas. And they say it was burning in air. So we have oxygen. And whenever a hydrocarbon burns in air, you can always produce carbon dioxide and water. And all we had to do is balance the carbons first, and then the hydrogens, and last would be the oxygen, and everything seems to have balanced out. We have 2 carbons on both sides. We have 4 hydrogens on both sides, and we have 6 oxygens on both sides. That will give you 15 marks. And then the final question, which seemed to be a problematic, and this is what I tell students now, don't underestimate CXC. And they like to bring green chemistry, they love to bring it, but you could have used a bit of common sense, or maybe you could have transferred some knowledge that you would have gained along the way during your high school tenure, if you didn't study this section, because you would have done this in integrated science somewhere if you had a teacher that was able to cover this syllabus. So the statement says, a chemical factory produces pesticides, fertilizers, and plastics using synthetic raw materials. The factory has been in operation for the past 5 years and is located near agricultural lands in a small rural community. Recently, the residents of the community have reported significant loss in plant and animal life due to increases in air pollutants, non-biodegradable solid waste, and algal growth in the nearby waterways. The increased toxicity has impacted the local agricultural economy. State 2 examples of pollutants, air pollutants. So 2 examples, this is a factory, chemical factory. Air pollutants could be carbon dioxide and carbon monoxide. And it says suggests 3 substances found in products produced by the chemical factory that may have contributed to the increased algal growth in the waterways. So what could have contributed to eutrophication, which would be, the suffocation of the aquatic life in the waterways. So Could be phosphates, nitrates, and sulfates. Could have been, filtered out into the waterways. This says define the term green chemistry. Well, I took this exactly from the book. Green chemistry deals with how to prevent harm in the environment. This is done by improving chemical processes and manufacturing techniques for making materials such as plastics, clothing, and glass. Now, you could have had a simpler one. It's just one mark. You could have said something like green chemistry deals with how to keep the earth clean by reducing the amount of pollution in the air and in water. You could have said it in a very simple way, right? No, there's 3 principles of green chemistry. So there are 12 of them. I picked some easy ones. I said prevention, reduction of waste is better than having to treat it after it's formed. Monitoring to prevent pollution and minimizing chemical accidents. This is explain how any 3 principles of green chemistry can be used by the factory to minimize the impact of pollution on the global agricultural economy. Bear with me. So waste can be reduced. How? Filters can be used to remove dust and particles from chemical plants and power stations. Air is drawn through the filters and dust collects on the outside. And we can also use catalytic converters to reduce the emission of harmful gases such as carbon monoxide and nitrogen oxides from petrol engines. That's if you have the car, but just put it in there. So harmful nitrogen oxides are converted to harmless nitrogen, and toxic carbon monoxide will be converted to harmless carbon dioxide. And we have a little equation there. Now, the amount of pesticides and fertilizers leaking into the nearby open body of water can be monitored and rerouted away from the open body of water. Such waste can be collected and recycled for use elsewhere. Like you could use the waste to make fireworks. You could use it to make more fertilizer. So things like that. Minimize chemical accidents from occurring by implementing more environmentally friendly protocols, by carrying out supervised exercises in the workplace. Like, let me see how we could supervise. So basically, instead of allowing subordinates to just do the job on their own, you train them properly. You have proper training. You implement proper training programs, and you have them ongoing, because you need to make sure you let your staff know the importance of performing chemical experiments efficiently so that they don't affect the environment. Well, that's it for now. I hope this helped. I try my best to keep the video as short as possible. If you have any questions, you could always contact me via the Science Hub, skb.com. Okay, there's a website, and also you can use the same name, the Science of skb at gmail.com. All right, so see you around. I hope this test wasn't too hard for you. On a scale of 1 to 10, with difficulty, I give this test, let's say, a 7. And I put 7 because this test required a lot of endurance. It was very long. I wrote it up last night and I fell asleep, so I wasn't able to post right after. I found it to be very long, and also there was some unfairness in the first question in terms of when you look through your textbooks, I don't see any calculations for heat of reaction. There are more calculations for heat and neutralization. There's like examples for that. So don't feel bad if you didn't know how to carry out a heat of reaction equation. As when I looked at the concise text, Collins' concise text, and I looked through the physics study guide, which is what students are encouraged to buy, It was not in there. I looked through the old Muhammad and Muhammad text. It was not in there. The only other thing I had to look through was probably, I don't even know. I haven't seen it. So let me know if you see it somewhere. I might have to look through an old Inti book or something. But anyway, that's me just rambling on. Have a good night or good day, whatever time you're looking at this. And I hope I was able to help you out. All right. Bye. See you around later.